Hello everyone, I am Dennis from the Edge Computing Division at EverFocus Electronics. Today, I'm honored to discuss advancing next-generation AI vision applications. In recent years, generative AI has been developing rapidly. Not long ago, version 5.6 of ChatGPT was released, and now DeepSeek is also catching up fast. The development of generative AI has evolved from understanding text to now understanding visuals. And moving forward, another area related to visual development is also thriving. Next, I'm going to introduce to everyone how we can combine large language models with image and visual processing, and also touch on the development trends of AI agents and physical AI. Looking at AI vision, if we review the past decade, in the past, our use of images was mainly for recording and playback. All right, and then later on, we started to introduce detection features, okay? Like being able to recognize people and license plates. And now, with the introduction of large language models, LLMs and VLMs, we can start enabling images to be understood, giving them the capability for this kind of understanding. So looking at this development trend we just talked about, we can see that there are about 5 main trends right now. The first is that today's AI vision emphasizes real-time processing. It needs to be able to analyze images instantly, not send them back to the cloud and wait a few minutes for a response. All right, next is multimodal AI. In fact, a single AI model can now start to recognize both text and images at the same time. That is correct. At the same time, it can also seamlessly incorporate data from sound, text, and sensors to carry out comprehensive multimodal processing. All right, next, when it comes to these computing environments, we're actually entering the era of edge AI computing because what they require is real-time performance as well as high reliability. Next, regarding physical AI, we're starting to see it understand things. From there, it develops autonomous capabilities, enabling inference. Once it infers, it can analyze and suggest. It can even manage cross-system scheduling, effectively integrating AI agent capabilities. Starting over on the far left, we have the integrated camera module, which is responsible for collecting all IoT-related data. It can utilize various communication methods, such as standardized protocols like RTSP, MQTT, and ONVIF, to effectively manage and control the camera. After the video comes in, we can actually use well-known AI models like YOLO, and the computing environment might be something like NVIDIA's TensorFlow or Intel's OpenVINO. These kinds of AI engines are frameworks to run inference. And when combined with what we just mentioned, like LLMs and VLMs, it can start to have the capability for understanding. All right, so after integrating with the AI agent, it can begin to handle things like process arrangement, planning, and even coordinating operations between various systems. All right, so in AI edge computing, the reason for the explanation on the previous slide is that you can actually see the formation of an AI pipeline. Now, the trend for this kind of AI pipeline is that deployment is starting to move from the cloud toward the edge. So why is edge computing, this kind of edge side processing, becoming increasingly popular? Mainly is because edge computing has certain advantages, such as low latency, and it can also protect data privacy. Since the data doesn't need to be uploaded to the cloud, some image data, for example, can be collected directly at the edge, which avoids the risk of data leaks. Also, its reliability tends to be higher, and because of these computational characteristics, it can reduce our reliance on cloud-related costs, and it also lowers bandwidth requirements. All right, so here at EverFocus Electronics, when it comes to AI edge hardware platforms, actually, it's not just a single type of platform. Instead, there are various CPU architectures and different SoCs released by major manufacturers. Each society or CPU actually has its own society or SOM, and each has its own characteristics. They're designed with different hardware configurations based on the specific application scenarios. Currently, the mainstream platforms we use are NVIDIA, Zwoi Technology mentioned NVIDIA's Jetson platform, plus Intel and Qualcomm. These 3 platforms are the most common. So when we design these kinds of edge AI PCs, In addition to tailoring their I/O features to meet the needs of different application scenarios, we also create different product combinations based on their computing power. Providing a set of standard APIs for customers to integrate is actually also a very important capability. All right, so based on this kind of AI platform, we've actually developed three sets of AI solutions. They're applied in different areas, such as video security monitoring, which we call Aegis. Next, we also have a solution for smart manufacturing in factories, used for defect detection, called Omnis. And the third one is used in education. It's a tool that assists teachers with group discussions in the classroom, called Minerva. At the same time, it can also handle AI model management. AI model management actually includes version control, deployment, and the entire AI model training cycle. Next, through OTA remote updates, since this is actually a platform, it's not just about running the AI model. The key point is really about maintaining long-term operation, including updates, management, and deployment. So the OTA feature actually plays a pretty important role on this platform. All right, next is system integration. Although the AI platform is important since it handles AI recognition, including image recognition and so on, the most crucial part is actually connecting the recognition results to each company's internal systems. So after developing this kind of platform, what will be the next step in the evolution of our AI vision? What we're seeing now is that the AI agent, which we've been hearing about a lot, is starting to gain a lot of attention lately, and there's also a lot of buzz around physical AI. Recently, you often hear about people raising lobsters. I'm not sure if any of you have heard about this, but this is actually the beginning of an AI agent trend. All right, so next up is really about the integration of agents and physical AI. When physical AI starts to be implemented in robots, the next question becomes, how do we make sure these robots are safe and trustworthy? How do we ensure that the actions performed by these robots won't make people feel afraid? This extends to robot safety, including traditional physical barriers, emergency stops, or electronic fences. We're now incorporating visual recognition using cameras. For example, when a person enters an AMR's workspace, the robot instantly locates them and responds in real time, either by rerouting or pausing its operation. In addition to that, of course, there are also various international safety certifications. These are all areas that will continue to develop in the robotics industry.
Hello, everyone, and thanks for joining today's seminar on Robotics, Technology, and Industry, System Integration Exchange. I am the moderator for today's seminar, and I'm a supervisor at TAIRO, the Taiwan Automation and Robotics Association. Our association has always worked to promote Taiwan's strengths in technology and manufacturing. Whether we are matching the US in tech or Europe in manufacturing, we truly excel in both areas. We aim to integrate these two ecosystems to boost our robotics industry's global competitiveness. Today's forum explores how the domestic industry faces tech challenges and market opportunities. Regarding the integration of AI vision and robotics, where is the fastest growing application market lately? How do we link platforms, algorithms, and edge computing to help clients deploy fast? And in this field, what opportunities does Taiwan have to build irreplaceable capabilities?
I'll turn it over to Secretary General Chen. Thanks, moderator. I should say that based on what we've seen this year, the highest market demand still comes back to Taiwan's manufacturing industry. As the other speakers just mentioned, with the industry thriving, it's really about inspection and how to keep constantly improving yield rates. So actually, inspection is an ongoing issue, how to keep improving production yield. Even if you reach 99.9%, you can still keep pushing for more nines after the decimal point. So the pursuit of continuous improvement is something that will always be happening. Well, actually, we've noticed this ourselves. For example, at our usual Computex show in June, we've done several live demos, and one of them was a defect detection demo. This demo, for all the visitors, was actually the thing they cared about the most or found the most appealing. Even if I put a robotic arm next to it today and I can control its value, the real questions people ask are still about this so-called inspection. They care about things like how long it takes to deploy this to the factory, how long the AI training will take, what level of accuracy it can reach, and whether it can be integrated with their existing systems. So this issue actually comes back to our own strengths here in Taiwan, especially in the area of advanced manufacturing. All right, so that's also why actually in the past, because we started out in vision, developing so-called NVR systems, that's how we got our start. With the advancement of this kind of technology, we also started to realize that if we could begin to integrate vision into everything we do and bring in image recognition and AI-based recognition, we could start to develop further. In addition to our own edge device design capabilities, we also needed to continue expanding outward. Because just making an AI box, honestly, is a very low margin business. Just like the previous speaker mentioned, what we really need to do is keep building upward, stacking layers until we have a complete system. Within our own capabilities, after we've designed this Edge AI box, our next step is actually to start integrating various sensors. Oh, actually, system integration is something that takes a lot of work behind the scenes, and it's also where the real value comes from. Once we have the AI box, we can start integrating all kinds of sensors and various cameras. After integrating these peripherals, we need software that can showcase them. At the same time, this software isn't hard-coded. It's flexible and can be quickly implemented. This allows customers to customize it themselves, or we can help them, which shortens implementation time. I think we've been continuously expanding from our foundation. Based on our core vision technology, we're constantly extending further. Oh, we aren't able to deliver a complete, fully finished system, but what we can do is take these semi-finished products and package them up so that the next party, like other system integrators or even customers with development capabilities, can take them and quickly develop further. And even if the customer doesn't have that capability themselves, we can also help them with customization. So I think this is what we're seeing in Taiwan right now, where we believe our niche lies and where we've been putting in our efforts. Thank you.